Assalamu alaikum, dear students. Let's go to the next part of redox reactions. Now, in this part, we'll discuss about types of redox reactions. And in this session, I'll be discussing about two important types. One is combination, and the other one is decomposition redox reaction. So, totally, there are four important types of redox reactions based on how they take place. So we classify them into four types. So first is combination redox reaction. Name itself is telling what is going to happen. Name itself is telling what is going to happen. That is, combination of species will take place, right? So combination reactions or combination redox reactions are those where a reactant or both reactants must be in elemental form, right? How when you will call a redox reaction a combination reaction, a reaction will be called as a combination redox reaction where a reactant or both the reactants must be in elemental form. Generally, I can write like this: A plus B gives AB. Combination redox reaction I can write like this: A and B are the two reactants and they are forming a product AB. What is the requirement? Both the reactants should be in elemental form, or at least one should be in elemental form. Then only you will call those redox reactions as combination redox reaction. Say for example, H2 plus Cl2 gives 2HCl. First, you have to check whether it is a redox reaction or not. Now, H2 oxidation number, what we can take? It is in elemental form. We take its oxidation number as 0. Chlorine, it is also in elemental form. Its oxidation number is taken as 0. Now, this is a compound. Hydrogen is taken as 1 and chlorine is taken as -1. Right? So, from hydrogen to hydrogen, what is happening? There is increase in oxidation number. So, you will call this as oxidation. And from chlorine to chlorine, what is happening? There is decrease in oxidation number. We'll call it as reduction, right? So based on this, we can say it is a redox reaction. And is it satisfying this condition? Yes, because the reactant or both the reactants must be in elemental form. So here we find both the species are in elemental form and they are forming a product. So it is an example for combination redox reaction. Okay, so in the examination, rarely they may ask you what is combination redox reaction. Instead, what they will give some equations, they will give some reactions, and they will ask you what type of redox reaction it is. Okay, आपको जो है इक्वेशन रिएक्शन दिया जाएगा, आपको पूछेंगे कि ये कौन से टाइप का रेडॉक्स रिएक्शन है, राइट? डेफिनेशन और एग्जाम्पल पूछ सकते हैं बहुत कम, लेकिन ज्यादातर 1 मार्क के क्वेश्चंस आते हैं. तो 1 मार्क के क्वेश्चंस में आपको जो है रिएक्शन दिया जाएगा और आपको आइडेंटिफाई करने के लिए बोलेंगे कि वो कौन से टाइप का रिएक्शन है. ओके, वन मोर एग्जांपल इफ आई टेक sulfur dioxide, when it combines with oxygen, it produces sulfur trioxide, right? So if I take this as A, this as B, and this will be the product AB. Okay, so here out of the two, only one is in elemental form. Oxygen elemental form hai, O2, because it is combined with its own atom. Elemental form oxygen, we take it as 0. Now here sulfur dioxide is there. Sulfur oxidation state, you have to calculate it. How you are going to calculate? By taking it as X, right? SO2, sulfur will be taken as X plus how many oxygen? 2. Oxygen charge is always -2. equal to 0. So x minus 4 equal to 0, x is equal to 4. So oxidation state of sulfur is plus 4. Whereas here when you talk about sulfur, same way SO2 you have taken, you have to take SO3. Sulfur will be taken as x plus 3 oxygen atom, oxygen charge minus 2 equal to 0. So x minus 6 equal to 0, x will be equal to 6. So here the sulfur is plus 6. Oxygen as usual minus 2. So what is happening to sulfur from here to here? What is the change? There is increase in oxidation number. From plus 4 it is becoming plus 6. So it is undergoing oxidation. Oxygen to oxygen, what is happening? From 0 to minus 2. Here also minus 2, here also minus 2. You cannot connect it, because you have to find out those species which are undergoing a change. So this species and this species you will connect. Here it is 0, here it is minus 2. There is decrease in oxidation number, so it is reduction. Right? So it is a redox reaction and two species are combining to form the product. Right? So these are examples for combination redox reaction. One more example we'll take up. You check out whether it is a redox reaction or not. If it is a redox reaction, find out which species is undergoing oxidation and which species is undergoing reduction. Methane combining with oxygen produces carbon dioxide and water. Right? So in general, what one more point we can remember is combustion reactions. All combustion reactions, they belong to combination redox category, because combustion reactions are those where a species combines with oxygen. Oxygen is there means it will be definitely in its elemental form, right? So a reactant means at least one reactant must be in elemental form. Okay, so this also is an example for combination redox reaction. Now you find out which species is undergoing oxidation and which species is undergoing reduction. Okay, next, decomposition redox reactions. It is the opposite of combination redox reactions. In decomposition, what happens? AB splits up into A plus B, and after splitting, whatever components you get, at least one should be in its elemental form, right? So it is opposite of combination. In this type, a compound splits into two or more components where at least one must be in elemental form. आपको जो product मिलेंगे, कोई एक product at least वो elemental form में होना जरूरी है, right? जैसे कि example, if you take potassium chlorate, when you heat this compound, you will be getting potassium chloride plus oxygen gas. You will be getting potassium chloride and oxygen gas. Okay, so here when you check the oxidation states, potassium is an alkali metal, its charge will be 1. Chlorine you have to find out. How you are going to calculate? By taking chlorine as X. So potassium is 1, chlorine will be taken as X plus oxygen 3 into minus 2, that will be equal to 0. Okay, so 1 plus X minus 6 equal to 0, X minus 5 equal to 0, X equal to 5. So here chlorine charge is plus 5, oxygen as usual minus 2 होता है, potassium again here plus 1, chlorine will be minus 1, and this oxygen, it is in its elemental form, we take it as 0. Okay, so here chlorine to chlorine, there is decrease in oxidation number from 5 to minus 1, so it is undergoing reduction. Potassium same, you can't take in redox, Whereas oxygen, you can see here it is -2 and here it is becoming 0. -2 to 0, there is increase. So it is undergoing what? Oxidation, right? So it is a redox reaction and the compound is splitting into two components, and out of two components, one is in its elemental form. So such redox reactions, we call them as decomposition redox reactions. They are called as what? Decomposition redox reactions. Okay. One more example we'll take. Water, when it splits up, it will split up into hydrogen gas and oxygen gas. When you carry out the process of decomposition of water by different methods, it will decompose to produce hydrogen gas and oxygen gas. It is also a redox reaction. So you can see here, hydrogen, it is always taken as +1, oxygen is always taken as -2. Here both the products we are getting in elemental form. Hydrogen elemental form 0, oxygen elemental form 0. See what is the change? Hydrogen from +1, it is becoming 0. There is decrease in oxidation number. So it is what? Reduction. Oxygen from -2, it is becoming 0. There is increase in oxidation number. So it is oxidation. Okay. One more example, you try this one. Sodium hydride upon heating produces sodium and gives out hydrogen gas. So this is also a decomposition redox reaction where a compound is splitting into two or more components and at least one will be in elemental form, hydrogen elemental form. Now you find out by yourself which species is undergoing oxidation and which species is undergoing reduction. Okay. Now if I take calcium carbonate splitting into calcium oxide plus carbon dioxide. Here also it appears same like decomposition. Calcium carbonate, no doubt it is decomposing to produce calcium oxide and carbon dioxide. Upon heating, it also decomposes to produce calcium oxide and carbon dioxide. But this is not a redox reaction. This is not a redox reaction. Why? Because at LHS and RHS, both side, reactant and product side, the oxidation number of all species will remain same. हालांकि ये डिकम्पोजिशन ही है, नो डाउट ये डिकम्पोजिशन रिएक्शन है, लेकिन डिकम्पोजिशन रेडॉक्स रिएक्शन नहीं है. रिमेंबर, इट इज नॉट ए रेडॉक्स रिएक्शन. Okay, why? Because is calcium always +2 because it is an alkaline earth metal. If you calculate for carbon, you will get +4. By taking x, when you calculate, you will get +4. Oxygen is -2. Here also calcium alkaline earth metal +2. Oxygen always taken -2. Carbon also, when you take x and calculate, you will get +4 and oxygen is -2. So there is no change in the oxidation number, so it is not a redox reaction. Okay. So decomposition redox reactions, when you are writing the examples, first you have to check whether they are redox or not. Then you have to apply the definition. That is, the compound should split up into two or more components and one must be in elemental form. Okay. So in next session, we'll see the other two types of redox reactions. One is displacement redox reaction, another is disproportionation redox reaction. Okay.